Welcome to my channel Electronic Science Tutorial. Today I will discuss the basic and fundamental of operational amplifier circuit from NET syllabus unit 4. Okay, so without any time waste, let's start our class. Now the first basic part of the fundamental part of the operational amplifier, which is known as op-amp. This is the short name. Op-amp is a best example of a general purpose linear integrated circuit. It's a direct coupled high gain differential amplifier. Why it is called direct coupled high gain differential amplifier? I will discuss briefly in next class. Okay. Next, the op-amp is a basically the significance of the term that is operational. Okay, and the significance of the term that op-amp can perform some mathematical operations. That's why it is called operational amplifier. Which type of operation it can be done? That is, it can be done as summation, subtraction, integration, and differentiation. Op-amp are important in analog computers also. Op-amps can be used in signal amplification, waveforming, servo controls, impedance transformation, active filters, oscillators, voltage regulators, analog to digital converters, and digital to analog converters. Op-amps are also useful in communication equipment, instrumentation, and data processing system. The advantage of op-amp is that the negative feedback can be applied. How we applied negative feedback I will briefly talk about in the next class. Now only you know that the negative feedback can be applied in the op-amp. The performance of the op-amp with negative feedback is controlled by the feedback elements, and these elements is independent of the characteristics of the transistor and other elements that constitute the op-amp. The op-amps are inexpensive and temperature stabilization. The user of the device need to know the detailed internal circuit configuration of the op-amp. That's why in next slide I will talk about this topic, that is the circuit symbol of op-amp and the pin configuration of the op-amp. Okay, so these are the basic part of the operational amplifier or op-amp. That is, op-amp is a direct coupled high gain differential amplifier. Op-amp can perform some mathematical operations. Negative feedback can be applied in the op-amp, and also op-amps are inexpensive and have temperature stabilization. Okay. So what is the circuit symbol of op-amp? This is the circuit symbol of op-amp. Here this is input 1, which is called non-inverting input. This is input 2, which is called inverting input, and this terminal is called output terminal. So here we saw two input terminal. One is non-inverting input terminal, which is represented by positive terminal, and the second terminal is the second input terminal is the inverting input terminal, which is represented by negative terminal, and the output terminal. This is the output terminal. Non-inverting input, how the non-inverting input terminal works, that if we applied some positive voltage or some negative voltage, this terminal cannot invert the input voltage. If we give input in input terminal positive voltage, we get positive terminal in the output. Or if we give negative voltage in the input terminal, we get negative output in negative output. So the voltage cannot be changed if we applied the voltage in the input 1 terminal, that is the non-inverting input terminal. The significance of the name is non-inverting input terminal. That means it's not invert any voltage. If we give positive voltage, we get positive voltage output. If we give negative voltage, we get negative output. But when we use the terminal 2, that is the inverting terminal, in this case, that is, if we give uh, positive voltage, we get negative output. If we get negative voltage, we get positive output. That means this input terminal 2, that means inverting input terminal. The significance of this terminal is the inverting input terminal. That means it invert the voltage. That means if we when we applied positive voltage, it will invert it to a negative voltage, and the output is in the negative output. And when we give the positive voltage, when we give the negative voltage, then we get the positive output. So here we saw the two input terminal. One is non-inverting input terminal, another one is inverting input terminal, and where we applied the voltage, input 1 or input 2, and the output is depend on this basis of the input 1 or input 2. Okay, so this is the circuit symbol of an op amp. Okay, now the op amp, we know the op amp is an integrated circuit. So in integrated circuit means in IC form, the op amp looks like this. Okay, so this is the pin configuration of op amp. Here we saw the total 8 pin. This is the identification marks, and the chip number is IC741. And this, from this identification marks, the left side pin is offset null 1. This pin name is null pin. Next, 2, this is called inverting input terminal. 3 is called non-inverting input terminal. 4 is negative supply. 5 is for offset null. 6 is for output. 7 is for positive supply, and 8 is no connection. Op amp works in the plus minus 12 volt or plus minus 15 volt. That means IC741 works in the plus minus 12 volt or plus minus 15 volt. When we use plus minus 12 volt, that means negative 12 volt is applied in the terminal 4 of this IC, and the positive 12 volt is applied to the terminal 7 or the pin 7 of this IC chip. Or if we applied plus minus 15 volt, then negative 15 volt is applied in the pin number 4, and the positive 15 volt is applied in the pin number 7. So this is the pin configuration of the IC741. How we work with this IC, we all discuss about this topic in the next class. So that's all today's class. That is, this is the pin configuration. Okay, number 1 is null point pin, number 2 is inverting input terminal, number 3 is non-inverting input terminal. In 4 we applied negative supply, 5 is for offset null condition, 6 is for output terminal, 7 is for positive supply voltage, and 8 is no connection. So the pin configuration is the op amp is that, and the IC chip number is 741. Okay. Now, what is the ideal op amp characteristics? First one is, ideally the first characteristics has an infinite voltage gain we get from an op amp. Next, an infinite input impedance, zero output output impedance, an infinite bandwidth, characteristics not drifting with temperature, and the output voltage is 0 when equal voltages are applied to the input terminals. These all are the ideal op-amp characteristics. An infinite voltage gain, an infinite input impedance, 0 output impedance, an infinite bandwidth, characteristics not drifting with temperature, output voltage is 0 when equal voltages are applied to the input terminal. But practical op-amp characteristics are differ from the ideal op-amp characteristics. How? For practical op-amp, the voltage gain is not infinite. It's of certain value, that is 10 cube to 10 to the power 6. Input impedance is not infinite. It's have certain values, that is in between 150 kilo ohm to few hundred mega ohm. Output impedance is not lies in the 0. It has lies in the range 0.75 to 100 ohm. Bandwidth must be finite. The practical op-amp characteristics do not drifting with temperature, but ideal op-amp characteristic drifting with temperature. And for this purpose we have to perfectly balanced to a op-amp when we practically work with the op-amp, and the output voltage is 0 when equal voltages are applied to the input terminal. This is also the ideal characteristics, but practically we not get the output voltage is perfectly 0 when equal voltages are applied to the input terminals. Okay, so instead of infinite voltage gain, for practical op-amp we get 10 cube to 10 to the power 6 voltage gain. Instead of infinite input impedance we get 150 kilo ohm to few hundred mega ohm input impedance. Instead of 0 output impedance we get 0.75 to 100 ohm output impedance. A finite bandwidth we get, characteristics change with temperature, and for practical op-amp, and for practical op-amp we do not get output voltage ideally 0 when equal voltages are applied to the input terminals. So these all are the ideal op-amp characteristics which are differ from the practical op-amp characteristics. Okay, and these points are very much important for exam purpose, right? So that's all for today. Thank you. If you like, share and subscribe my channel. Thank you.